Okay, I'm going to attempt to make a video here to try to prove a concept. This is a primary battery that runs this coil. This coil generates electricity to charge this capacitor, which runs this coil. So everything from this coil back is free energy. And what I did is I hooked up a little electric motor to the capacitor to show that as the first coil is charging the capacitor, that no matter how much load I put on this capacitor, it doesn't draw any more energy out of the primary battery. So hopefully it'll prove that everything from behind this coil is all free energy. This coil is being ran by energy coming from that coil. So these are the meters. This is the radiant charge coming off of the second coil, and it's going to this battery right here. Radiant charge. Those primary amps, primary voltage from the primary battery, which is that battery. Okay, so I'll go ahead and fire it up. I'll put a load on it, so take the load off and hook the power up. Here we go. Spin a little faster. Okay. You can see this is 50 milliamps, and this is the capacitor. So it's charging right now. Plus I have this coil turned on, so the energy that's going in this capacitor right now is running that coil at the same time. And at the same time charging. I know that looks like one there, that's 8. Okay. So it'll keep going. And the main thing is when it all evens out, I'll even put a load on it. But right now the battery is 1288, but it'll come down little by little as it draws more energy from it to run the first coil. So we'll let it gain up as much speed as it can. And this started out at 12.33, I think, so it's charging this. Now it's 12.35, which that's the radiant charge going to that battery right there. Which that charge is coming off the second coil, which is totally free energy. What's running that coil is the energy coming off of that coil. And the energy coming off of that coil that is charging this capacitor does not come out of this battery. That's what I'm attempting to prove right now. Okay, it's still climbing. So I'm going to wait until it's done climbing. Okay, it's going down now. So what I'm going to do is I'm going to add a load to it. Because when I add a load to it, something strange happens. It draws a little bit of energy and starts charging that. Now that'll come up to around 7.5 volts. So I'll give it a minute and let it get where it's levels out. And around 7.3, 7.5 is where it'll end up. Then that second coil will be drawing the energy out of this capacitor pretty much at the same rate that it's putting it in from that coil. With the energy it takes, this is a bifilar coil. It's got one wire for a trigger wire and one wire for a pickup wire. The trigger wire takes a little bit of current from this battery, or a little bit of voltage, I don't even know that it's current. I think it's just voltage. But I think it takes a little bit of voltage from that battery for the trigger to pulse the motor. But the second winding, the pickup winding, is just producing energy. When it shorts out the coil, this circuit here captures the back spike, the back EMF, and that's what it sends to this capacitor. Okay, so it looks like it's going to even out. Well, it's still climbing a little bit, but just wanted to show. Okay, so the primary battery, that battery right there, is 12.8 right now. So what I'm going to do is I'm going to turn this motor on, let this motor coil keep running, plus the draw from that there. It'll run the capacitor down to around 1.5 volts. So I'm going to turn it on. This switch right here, and you'll see it's running the capacitor down. And look at the primary battery. It does not draw any more juice out of the primary battery to run that. Now it's slowing the wheel down, so it's triggering less. So now it's down to 40 milliamps. Once it gets down to 30 milliamps, I'll shut that motor off and let it build the capacitor back up to run the. Okay, now I'm going to shut this motor off, so that, because if this goes down to 2, it'll shut off the circuit, and I don't want to shut the circuit off. So, but that'll show right there that when I drain this capacitor, it doesn't have any effect on the primary battery. Actually, it gains a little bit of voltage because the wheel's turning slower and triggering less. So it actually draws less out of, from the first coil, it draws less to run the motor, the slower the wheel goes. Because it triggers 6 times per revolution, so the faster it goes, the more times it triggers. A little bit more draws out of the battery. It'll only draw up to like 150 milliamps. Actually, I'm thinking it's millivolts, but because it's odd, because the voltage on this battery comes down at the same rate that this goes up. So if this, say this right now is at 80, this is 83. When this goes up to 90, then before this goes up to 100, that'll go to 82. See? So that it stays at the same rate. So I don't think that current and voltage go at the same rate like that. So I'm thinking that this was probably voltage and not current. But I'm not 100% sure. So, but we'll do this one more time. This time I'm going to go ahead and shut off the second coil, so it'll, and just run that motor to run it down, because that coil takes a lot less energy from this capacitor than that little motor right there. That little motor will drain it down pretty quick. So first I'm going to shut this coil off. So now it's only running on one coil. The capacitor is going to continue to charge, and the wheel will slow down a little bit, so it'll start drawing less energy. So now I'm going to turn this motor on. And 12.82, as it draws the voltage down. I'll even take a load off the wheel, so maybe it'll stay running. That's down to 70 milliamps. That's coming down. 12.83. That came up a little. So right now that little motor there is running on the radiant energy, the back spike that's captured off of that coil. looks like it's going to stay around 70 milliamps. 1.89. So I'm going to go ahead and turn the coil on now and see what happens. So turn this coil on. Now it's drawing a little bit more to run that coil too, but not much. See how fast it ran it down with just that motor. It doesn't take much to run that coil, that second coil. And to show you what I mean, this primary amps is 70 milliamps. Primary voltage is 1283. I'm going to shut this motor off. That coil's still going to be on. So I'm going to shut this motor off. Now it's off. Now watch how fast the capacitor voltage comes up. And as it comes up, it's triggering that second coil, so it's running the motor faster. And the faster it runs the motor, the more current's going to take out of it. But it won't take out no more than like 120 milliamps. And the primary voltage and the primary current comes out at the same rate. That's 100 milliamps right there. 110. It's 81. So when this here hits 120, then that'll hit 80. Actually, it hit 80 first. So then this here will hit 120. Oh, nope, it's going down. Yeah, this is a phenomenon I'm not real sure about. See, that's still 81. This is back down to 70. And the wheel's still speeding up. Cool stuff. And the capacitor is coming down, so now I'll put a load on it. And then 70 milliamps, 60. Back to 70, there's 80. Now it's coming, now the capacitor's charging. Now the wheel's going slower and it's charging the capacitor more. I'm totally baffled by that. Which, do cool. And with the load on it, the capacitor, I've seen it up to 7.5 volts on just one pickup wire. So anyway, I was hoping that this would help. This will be a video to prove that everything from after that first coil there, from the pickup coil all the way back, and the second coil is all free energy. The capacitor still charging. 100 milliamps. 1280. And then the radiant charge, that was 1233 when we started. So it's not charging real fast because the pickup wire that's charging this battery is the one coming from the capacitor, which I'm using for the primary battery for the second coil. So it's only, 6 volts compared to almost 13. So my next step is to add more wire to the first coil and try to get it to charge the capacitor about the same voltage as the battery. Then the charge side of it, I'll add more wires to hit and try to get it to charge this the same charge that it's receiving. Then instead of going into a battery, it'll go into another capacitor, which will trigger another coil. Alright, yep. And this is the circuit. Anybody that might be interested. It's a pretty easy circuit. I have known nothing about electronics, so I'm learning a little bit, but Somebody on YouTube made this dummy proof for people like me, and it took a couple tries, but now that I got it, after I got the first one working, it's pretty easy to make another one. Okay. Radiant charge that comes off of this magneto. Basically what this is really good for batteries. I got an electric lawnmower that I pretty much wasted the batteries in because I forgot to bring it in when snow started flying and got the first freeze. And my batteries got puffy and wouldn't take a charge anymore. But I can charge it up with this. So it'll save me $130 for batteries. Alright. Okay, so this came up to 110 milliamps, and that went down to 790. Always at the same rate. Kind of cool. Okay. So I'm going to go ahead and unplug this. Now it's just running off of that coil and the radiant energy. And as it slows down, I'll take the drag off of it. And it'll run until it gets around 2 volts, I think. But you'll know when it stops triggering because it'll stop generating electricity too. When it stops taking it out, it's done. So now to run the capacitor the rest of the way down, I just turn this on. And that's it. Alright.